Good morning, everyone. Today we are going to start chapter number 4, Advanced Structural Modeling. Okay, Advanced Structural Modeling. This chapter consists of advanced classes, advanced relationships, interface, types and roles, packages, object diagram. Okay, so this chapter 3 is your basic structural modeling. Okay, chapter 3 is basic structural modeling. The chapter is consisting of classes, relationship, common mechanism, diagrams, and class diagrams. So that what the difference between that basic structural modeling and advanced structural modeling? In advanced structural modeling, we have seen that in basics that classes, then objects, class models. So in this chapter, we are going to see the same concept, but there is a this these are the advanced parts of the from that basic. Okay, so this is all advanced structural modelings. In that, we are going to see some advanced classes. Okay, so that classes may include constructor, destructor. Okay, constructor they include then objects. Okay, so objects with their responsibilities, classes with responsibilities. Okay, so here in abstract structural modeling, first we will see some basic concepts regarding classes, regarding objects, then relationships. Okay, so first we will see that we have already seen that what is the class, what is object. Okay, what is class model. Then now we are going to see that what are the classes, advanced classes. What is mean by advanced classes? Okay, so we a class is defined using the class keyword. Okay, where that C of that class is in small case. Okay, once that class is defined, then that instances means objects. Okay, so objects of that class can be created, and each instance of that class have a different copy of that object variable or instance variable, that is attributes or fields. Okay, once we have declared that class, then that class may have number of objects. Okay, number of different copy of that objects. Okay, that class or that objects may have that attributes and their fields and their types. Okay, so in advanced classes, that class is the keyword. Okay, in that that whenever we are going to create any object, that object consisting of that attributes and their fields, so that data fields may describe inside that class. Okay, that means that are the properties and methods of that objects. Okay, the data field means attributes and or the properties of that object. We can create different data fields in that object. Okay, whenever a class is created, after creating that class, we are going to create that object, and under that object we are going to create different methods or different data fields are there. So that while declaring any method, there are several method declaration parts. Okay, it has four parts, like method is having name. Okay, method name, then data type of the value returned by that method. Okay, so the data type of that method, then number of parameters we are going to pass to that method, that is third one, and fourth one is instructions inside that method. Whenever we are going to declare any method in the inside the class or inside the objects, that method declaration having four parts. Okay, remember that that method declaration having four parts: method having name, then data type of that method, then list of parameters for that methods, and instructions inside of that method. Okay, so that this is all about that advanced classes, that class is in what class includes, what class consists of. Okay, so first we will see some relationships. Okay, relationships in last chapter we have seen some relationships for that. Okay, then you already studied about constructors, what constructor is. Okay, constructor, destructors. So first we'll see that what is constructors. Here the constructor enables an object to initialize itself when it is created. Okay, whenever we are going to initialize that object of that class, that constructor is created. Okay, in object oriented programming you have seen that what is constructor and how or when it is created. Okay, so that constructor will be created whenever we are going to initialize, or whenever that object is going to be initialized, at that time that constructor is created. that constructor is having same name as the class name. Okay, the class name and the constructor name should be the same. Okay, they do not have any return type. Remember that constructor don't have any return type, not even void means null. Constructor should not be null. Okay, so that constructor should not have any return type. Okay, that this is because they return the instance of the class itself. Why that constructor is not having any return type or not even void return type? Because they return the instance of that class itself. Okay, so whenever we are going to declare a class in rectangle shape, okay, with class name, then we are going to declare class with all the necessary details like class is having name, then visibility or the attribute type. Okay, attribute type with like integer, roll number equals to like 1 2 3 with values. Okay, first section with class name, then second is with that data types or data fields with visibility, public, private and protected. We have seen that visibility is with their attributes or with their data type with their values. Okay, then in third section, that is we are going to use that constructor here. Okay, like stereotype declaration. Okay, that constructor with their argument list. Okay, and that fourth part for class diagram is that responsibilities. We have seen that. Okay, we will see in next some upcoming lectures that how to declare that constructor or how to declare the constructor inside the class diagrams. Okay, so this is all about constructors. Okay, constructor we have seen that it having same name as the class name. Then it is when it is initialized, when we are going to initialize the object, what it returns the instance of the class itself. Okay, this is all about constructors. We have seen about objects. Okay, that is all about classes, object and constructors. Okay, so now we are going to see that advanced relationships. Okay, so some advanced relationships. Okay, so what is relationships? We have seen in last sections that a relationship is a connection among things. Okay, there is a question in your MCQ for chapter number 3, that is what relationship is, what or dash dash is the connection among things. That relationship is a connection among things. Okay, so in object oriented modeling, the four most important relationships are: first one is dependencies, then generalizations, associations, and realizations. Okay, so these are the relationships in object oriented modeling. Okay, so that relationship is rendered graphically as a path. Okay, render as a path with different kinds of lines used to distinguish the different relationships. There are four relationships here. So to define or to graphically, they are rendered as or not denoted as with different kinds of lines like dotted lines, arrow lines, plain lines. Okay, to distinguish that different relationships. Okay, so first we will see in advanced relationship there are three kinds of relationships. Okay, these four relationships are in object oriented modeling. Remember that object oriented modeling having that four relationships like dependencies, generalizations, associations and realizations. Okay, in and in advanced, the that advanced relationships are three relationships are there. Okay, composite relationship, association and aggregation relationship. Okay, association, composition and aggregation relationships. Okay, in book you can see the diagrams for that classification of this advanced relationship, that association, aggregation and what composition is. Okay, we will see the all one by one. Okay, so first we will see the dependency relationship. Okay, dependency, we have seen in third chapter what dependency relationship is. Okay, it is unidirectional usage relationship between elements. Okay, here you can see the a dependency is a using relationship. Okay, using that class 1 or class 2, class 1 dependent on class B. Okay, for example class A and class B, class 1 is dependent on class B. That means class A uses some things from class B. Okay, so here you can see a dependency is a using relationship specifying that a change in specification of one thing may affect another thing that uses it. Like suppose class A is dependent on class B. If that class B is changes, or is there any change in class B's attributes, any methods, that means that will affect on class A, okay, because that class A is dependent on class B, okay. So but not necessarily the reverse, okay. That means if that class B is not dependent on class A, that means if any changes happen in class A, that means that it will not affected that class B, okay, because that class A is dependent on class B, not class B is dependent on class A, okay. So this graphically the dependency is rendered as a dashed line, okay, dashed line. A plain un add-on dependency relationship is sufficient for most of the using relationships, okay. However, if you want to specify a shade of meaning, the UML defines a number of stereotypes, okay. Number of stereotypes are defined for that relationships, okay, that may be applied to dependency relationships. For dependency relationship, there are so many stereotypes are there, okay. So we have seen the examples of dependency relationships in third chapters. Also, we have seen that relationships and their examples with their representation, okay. So there are many examples which are uh, we can give for the dependency relationships, okay. That result, for example, the your result, consider the class result and consider another class is exam, okay. So that result class is dependent on exam class, okay. Okay, that means this is the dependency relationship between class result and class exam, okay. So here you can see there are several. Mute yourself. Okay, so here you can see there are 17 such stereotypes, all of which can be organized into 6 groups, okay. There are 17 stereotypes for dependency relationship, okay. They can be categorized or organized into 6 groups, okay. So first there are 8 stereotypes that apply to dependency relationship among classes and objects in class diagram. Whenever we are going to draw the class diagram, okay, class diagram and object diagram, there are 8 stereotypes are there for that class and object diagram. First is bind stereotype. What it specifies, it specifies that the source instantiates the target template using the given actual parameters, okay. So bind stereotypes is there. Then derive, okay, it specifies that the source may be computed from the target. Here source means, source and target means that consider the class A and class B. Class A is dependent on class B, that means class A is source and class B is target, okay. Consider the scenario that, consider these examples while studying or while studying that stereotypes for that relationships, okay. Third one is friend, okay, friend stereotype. What it specifies that the source is given special visibility into the target, okay. Means that dependent class can access some features or some attributes from that source, okay, that will be visible to that target location from the source by using friend. If you are giving friends as a stereotype for any attribute or any special special data field, that means the data field is accessible or visible to the target class, okay. Then instance of, okay, instance of stereotype, it specifies that the source object is an instance of the target classifier, okay. So these are the stereotypes for that dependency relationship for object and class diagrams, okay, like instantiate, power type, refine, use. We have already seen these stereotypes in previous sessions, okay. So this is just a overview of your stereotypes. Here you can see bind includes a list of actual arguments that map to the former arguments of the template. Then derive, friend, this is all about the stereotypes here. Then next stereotypes, like there are 2 stereotypes that apply to dependency relationships among packages. We can use these two stereotypes for packages, package diagrams. Whenever we are going to draw the package diagram, at that time we can use the access as a stereotype and import as a stereotype. What access specifies that, it specifies that the source package is granted the right to reference the elements of the target package, okay. we can access that several packages from source to target or target to source based on the dependency. Okay, then import stereotype. It kind of a access that specifies that the public content of the target package enter the flat namespace of the source as if they had been declared in the source. Okay, we can import the packages or import some classes or import some namespaces from the source to target. Okay, yeah, these are the these two stereotype is for packages. Okay, for package diagrams. Okay, then third group is for dependencies. Okay, these are the another two stereotypes that can be applied to dependency relationship whenever we are going to draw the use case diagrams. Okay, that is extend and include. We have seen the use case diagrams. In that we have seen that extend relationship, extend stereotype and include. What extend is, it specifies that the target use case extends the behavior of source. Okay, extending and including. Okay, these are the two stereotypes for use case diagrams in dependency relationship. Okay, then another group is for, it consists of three stereotypes for whenever when modeling interaction among objects. Okay, interaction among objects, that is become, call, copy. Okay, these all the stereotypes for is your reference. Okay, these are not available in your books. Okay, these all stereotypes are useful whenever you are going to draw that diagrams for your projects. Okay, in whenever you are in soft, if anybody wants to become a software architect. Okay, so that time or at the end of your year you have to complete your projects. At that time you are going to draw some diagrams for your projects like behavioral, structural, all these diagrams. The diagrams, in these diagrams you have to use these stereotypes. Okay, then next one is, we can okay, so next these are all the stereotypes for, here you can see the one stereotype will encounter in the state machine. Okay, whenever we are going to draw the state machine diagram, in that you can use the state as a stereotype. Okay, then trace is another stereotype. Okay, these all are the 17 stereotypes under the dependency relationship. Okay, so this is all about dependency relationship in advanced relationships. Okay, then next relationship is generalization. Okay, generalization means when we can use the generalization whenever we are going to inherit anything from that superclass. Okay, that is generalization. Also inheritance is a relationship. Okay, so a generalization is a relationship. Here you can see a generalization is a relationship between a general thing. Okay, general thing means called the superclass or parent class. Okay, generalization from superclass or parent class, and a more specific kind of thing, that means a subclass or a child class. Okay, that is inheritance. In generalization relationship, instances of the child or subclass may be used anywhere instance of the parent apply. That means the child is substitute of the parent. Okay, that means the child can access some part from that parent. Okay, that is inheritance. A plain unadd-on generalization relationship is sufficient for most of the inheritance relationship. Okay, if you want to specify a shade of meaning, that means how we can define that generalization. Okay, that you can use the plain directed arrow. Okay, for that generalization. The UML defines one stereotype and four constraint. Okay, constraint, that means conditional conditions that may be applied to generalization relationships. Okay, what the generalization relationship, it it having one stereotype, that is implementation. Okay, it specifies that the child inherits the implementation of the parent. Okay, child inherits the implementation of the parent but does not make public nor support its interfaces, thereby violating the substantiality. Okay, that means that child class or the child or the derived class can acquire the properties of that parent. Okay, the child inherits the implementation of the parent, but that does not mean that it make that public, okay, that may be the violation of that sustainability, okay. Here you can see that advantage of that class hierarchy is to reuse the properties of base class into the subclass or that new class or derived class, okay. The properties means like attributes as well as methods from that superclass, okay. Then it describes a kind of each kind of relationship. What kind of each kind of relationship for generalization, okay. Here in generalizations, the classes are ordered within the hierarchy, okay. Like base class is called as the superclass and newly derived class is called as the subclass, okay. So superclass is the abstraction of its subclass, okay. It's the abstraction. Superclass is the abstraction of your subclass. Okay, like your specialization also allowed the capture of the specific set of objects that have not been distinguished by the classes. Okay, by considering my example, suppose you are having file and user. Okay, so that file and user is accessible by, and they're having some permissions. Okay, so what the generalization and specialization, these are two opposite viewpoint of concept of classification, okay. So that generalization is that arrow, if you have seen that generalization, okay, that means plain arrow, okay, that is that superclass is and subclass inherits the properties from superclass, and the specialization is the opposite, exactly opposite to that generalization, okay, that is specialization. That superclass is having subclasses, that is the generalization, okay. They like deriving two classes from the class, okay, like suppose consider the patient is one of the class, then their subclasses like inpatient and outpatient, okay. So this is like inheritance, multiple inheritance, you have seen that, okay. So there are some constraint are there in generalization, that constraints are complete. There are four constraints are there, okay. First one is complete, then incomplete, okay, then disjoint and overlapping, okay. These are four constraints in generalization, okay. Then yeah, that complete constraint, we will use the complete constraint when we want to show explicitly that you have fully specified a hierarchy in the model, okay. That means no one diagram may show that hierarchy, that time you can show use this constraint. Then incomplete, we will use this incomplete to show explicitly that you have not stated the full specification of hierarchy in the model, means one diagram may show everything in the model, okay. Then what is disjoint and overlapping? Here these two constraints apply only in the context of multiple inheritance, okay. Whenever we are going to use multiple inheritance, that time we can use the disjoint and overlapping constraint. We will use that disjoint and overlapping when we want to distinguish between static classification and dynamic classification. A static classification means disjoint and dynamic classification means overlapping, okay. That overlapping inheritance, okay, overlapping means the subclasses can inherit the data fields, that means properties and methods, okay. Data fields means properties and methods from more than one subclasses, that is overlapping, okay. That is overlapping in inheritance, okay. That means subclasses can inherit the data fields from more than one subclass, okay. Then disjoint generalization is just the opposite of overlapping inheritance, okay. It is the default constraint, that is disjoint, okay. We have seen the complete constraint, incomplete constraint, okay. That complete constraint specifies that no subclasses can be derived, okay. And incomplete constraint means superclass can derive any number of new subclasses, okay. These are the four constraints for generalization relationship: complete, then overlapping and disjoint, incomplete, okay. These are four constraints for generalization. Okay, so that's it for today's session. Okay, thank you.